Hello everyone, this is Sriharsh here, and welcome back to the live streaming of the part 3 of my Ludum Dare entry. In this entry, in this part, what I plan to do is add gravity, movement, and if time permits, the camera also. So this is all I have done in the previous part, and now I have to add the movement and add the gravity and make the camera follow the robot. So the first thing easy to do is the movement. So in the upgrade, I'll get the velocity vector to velocity is equal to get velocity. This is the current velocity, and initially I set this velocity to 0. Velocity set is 0. So that means there is no movement initially. So now if keyboard dot is pressed key A, the movement is WSD. So velocity dot x is equal to -4. The x component is -4. So in order, so we are moving left, and let's take minus equal to 4 relative velocity, and if keyboard dot is pressed key D, velocity dot x plus equal to 4. This 4 is the pixels, and we only update the animation if velocity dot x not equal to 0. And we may need to invert this. So okay, first let me see how this works out. Okay, I'm back. So when coming back, that should look back. So what we do is, let's just add a flip x first is, so get velocity dot x less than 0 question mark true or else false, and always don't flip. Okay, there is no need for this. If it's less than 0, invert it horizontally. So no, right, left, right, and left. But it is not that simple rotation is not enough, because see, if it just goes back, so we'll keep a direction. So public, okay, let's make it private enum the direction left or right, and private direction. Initially direction is equal to right. What will they say this is? direction equal to left question mark true. Otherwise, no flipping. Uh, this is also not needed. Ternary operators are unnecessarily doing ternary. Okay, now we'll have to add this direction equal to left and here direction equal to right. Okay, now it will be right and left and stay there. Now let us add the gravity. So the gravity acts every frame. So it's just as velocity dot y minus equal to sorry plus equal to because y is down in this axis plus equal to 4. Now if you run it keeps on falling. So we have to add a collision event with flow. So let me declare the collision. Collider dot register robot class with floor class, and we're checking these collisions. So in the robot, I'll now override the collision at OY public void collision entity to the other. This function is called whenever a collision event is happened. So let me check it. If other instance of flow, we just want to align with it. So align next to other. So let's see how this works out. Okay. This align now is not good. What we just say is just add the y. So vector to position equal to get position. We velocity to the velocity here. It is our position. So let's make it opus tipus for this position and opus for other others position. We just want to set our thing, our robot up, then up on the others. So tipus.y is equal to other position y minus height. So this height we have to find it as 5 times 48. So that's it. And finally set position to tipus. The position we just manipulate it. It should work. Okay, let's test it out. I'm taking off this and adding the robot here. So falls down. So gravity and movement is done. What I'm next doing is making the follow making the camera follow this robot. So that will be taken care in the update. We'll create a follow camera. This is a function that makes the camera follow. Private void follow camera. Okay. To follow this camera, we need to know the. Okay, let's first get the graphics studio. Graphics studio. We'll use this camera. So AutoCam camera is equal to g2d.getCamera. We now use this camera to follow our robot. Center, get position. So if this is the case, every frame position is centered. This is okay, but is not acceptable. That we don't want to the and the background too. So what I'll do is place it for the background. I will not be using Graphics Studio for the background. Instead, I will be using the batcher directory. So batcher dot draw texture tree uh, begin primitive mode dot draw triangle fence batcher dot end. This is the batcher, and the Graphics Studio overrides is extends from this batcher. So if you are using batcher directly, we are not using well, our cameras. The camera will not be affecting this batcher. So I'll first resources dot background dot bind. I'll bind the texture first, and now simply batcher dot vertex. It will be 0 0 the first vertex. Batcher dot vertex display width and 0 the first. Now batcher dot vertex add another vertex set 0 sorry display width display height. On the next vertex is at 0 and display height. Now finally I'll bind empty texture. So this is occurring because there is actually no texture here. We need another camera. Okay. Okay, instead let's make this -1 -1, the top left. So in -1, 1 is the top left, and width 1, 1, 1 is the rightmost, and this is the bottom right. So 1 and -1, and this is the bottom left. So -1, -1. I'm using these coordinates because right now there is no camera acting. So if you run this, you see a gray, so that is filling the screen completely. Okay, we are not setting the texture coordinates. So bachelor dot texture coordinates. And the first texture coordinate is 0, 0. Um, the texture coordinate at the top right 1, 0. Texture coordinate at the bottom right 1, 1. And the texture coordinate at the bottom left is 0, 1. So now it should render. Yeah, the background is always in place now, and even if you resize, background resizes perfectly. So we need another thing to fix. The camera should not be moving past the game. So for that we need another. So what I am going to do is I'm going to, in the play state, I'm declaring two constants: public static float level width, level width in pixels, and public static float level height, level height in pixels. In default, in the constructor, we'll construct them to 0. Level width equal to level height equal to 0. And here, we'll increase the level width. Level width is equal to the number of characters. Level equal to math.max. Level. Okay, we need tx, ty, tx plus plus. This is the tile x and the tile y. Now increase the tile x to 0, tile y. Okay, we are using x and y, so there is no need for tile x and tile y. Level width x and level height is equal to is just y, because okay, this is good enough. And we'll go to the robot class. Instead of centering to our position, we calculate which position we should center. So we need a temporary vector to temp is equal to vector to reusable stack of form, and we finally push it back. Okay, this is the width and height is not known. What we have to do is this we center to this temp instead, and right now this may be some junk values, so we set it to 0. So if we run it, the camera should no longer center the place. And if I remove this, okay, cam dot center. If I set it to position, it should work the same as it is. So let's set it to temporary, and the camera position is first set it to the current position. Okay, and we control temp. If temp dot x is greater than playstate dot level width minus the screen width is 800, so 400. So okay, wait. This should be in if this is straightened, temp dot x is equal to playstate dot level width minus 400. We are making the constant. If temp dot y greater than playstate dot level height minus it is 600 the total width, so total height of the display or the game resolution, so by 2 is 300. 300 temp dot y is equal to playstate dot level height minus 300. So now it should work. The height is okay, and let's go check the finally. Okay, it stopped moving. In the same way, we also should be able to make it in the left. So if uh, temp dot x is less than 400, temp dot x is equal to 400, and if temp dot y is less than 300, temp dot y is equal to 300. That is the lower boundaries, so it goes left and follows. So we have got the camera following the player. So this is end of this part 3, and in the next part I'll be adding up the jumping on the for the robot and the firing based on the space key. So thanks for watching. If you like this, please like, comment, rate, and subscribe. Thank you.